All right. So today I have my friend Hagay Lupesko. He is VP of Engineering at a startup called MosaicML, which uh, describes itself as a platform that enables you to easily train large AI models on your data in your own secure environment. So welcome to the Data Exchange Podcast, Hagay.
Hey Ben, thanks for having me. I'm actually an avid listener of your podcast, so it's fun to be a guest as well.
So so before we go into our main topic of the day, which is what I'm now calling decentralized custom models. So in this case, custom foundation models. So first, Guy, actually, you have quite an interesting background in that you're a technical person, but you did not come from necessarily an ML background, but you made that transition. So, and we'll talk about towards the end of the podcast, we'll talk about career related topics like how you transition from technical to ML and so on and so forth. But for the sake of our listeners, just describe your general background in ML prior to Mosaic. So I know that you worked at AWS and Facebook, but so briefly describe your background.
Yeah, so I mean, I did a lot of different things in my career. It was usually around software engineering, but it was computer vision for industrial applications and medical imaging. Before it was actually called AI, but it wasn't that different. And I was always working on that area between systems and algorithms, which I find really exciting. And then later in my career, I was at AWS. I had built SageMaker, helped build Onyx, worked on deep learning frameworks and services on AWS. And it was pretty early days, so that was exciting. And later I moved to Meta AI, where I worked on recommendation systems and foundation models for computer vision, language understanding, translation within Meta, aka Facebook. And then later on, I got to Mosaic, where I'm leading the engineering team.
So, as you described it, so you were at AWS very early on when deep learning was starting to be used by regular companies.
Yep.
And then you moved to Meta, where obviously they were using it heavily. So what was the difference between what you saw, so regular companies trying to use deep learning versus really one of the most leading edge companies in terms of using deep learning?
Yeah. So it's interesting, because I did get kind of the perspective of, AWS is the biggest cloud provider out there. Almost everyone's using AWS. And then it was interesting to see exactly what kind of machine learning different companies did. Now, mind you, this was circa, 2017 to 19. We launched SageMaker, and we already had a bunch of machine learning services back then. It was interesting that neural networks, deep learning was kind of thing everyone talked about, but hardly anyone actually applied it in practice. And then obviously it was very clear that the trend is going in a very specific direction, but still, the so-called traditional machine learning tools from, decision trees, linear models, there's a bunch of these algorithms. They're not as, performant as deep learning, techniques are. However, they work extremely well, and they work really well for small amounts of data. And back then, it was very useful, so everyone started with that. Now, moving to Meta, Meta was already heavily using deep learning, right, across almost everything. And I think when I got to Meta, it was, still a little bit of traditional ML being used, but definitely neural networks were ruling and applied, across the stack. And the way I kind of see this as, a company like Meta and probably the other big tech companies, they're living in the future, right? They're 3, 4, 5 years ahead of everyone else. So, I think that, where Meta was 3 years ago is where most other companies are now or are getting to today.
And as you point out, the traditional ML techniques, while they may not scale to massive amounts of data the way deep learning can, at least for in certain areas like tabular data, they're still quite the go-to tools, right? So I think obviously there are situations where companies who have the talent and the staff are moving, for example, their time series forecasting approaches towards deep learning, but I think that those are still exceptions at this point, right?
Yeah, it's an interesting question. You know, I think that the trend is ongoing. It's hard for me to say exactly how much, you know, traditional ML versus deep learning, but I would say that it's definitely easier to get started with traditional ML because of all the reasons we mentioned. And that's actually a good starting point if you're just, launching a service or building some kind of a model. It's definitely always a good engineering practice, actually, right? Not to over-engineer. Start with something basic that is working well. Once you ship it and you see it's working and it's effective, then you start optimizing. And then as you optimize, moving to more sophisticated machine learning techniques like, deep learning makes a lot of sense. But it's not necessarily where you want to start with initially for quite a few problems.
So let me ask you about deep learning frameworks, right? So obviously when you were at AWS, you folks were pushing MXNet, which didn't really go anywhere. So I think one thing that surprises me. So obviously when you read papers and research, PyTorch is dominant. JAX is there as well for language models, and people just say TensorFlow is dead. But I've been looking at job postings for years, and TensorFlow remains the dominant framework when people mention requirements in job posts. And I think that has to do with the fact that TensorFlow was the first viable tool for many companies that they could deploy to production. And honestly, when you're doing computer vision on the edge, so maybe you're still using TensorFlow. So what's your sense of deep learning frameworks and whether or not people should just forget about TensorFlow?
Yeah. So as you point out, I actually, back when I was at AWS, I worked quite a bit on MXNet. And MXNet, for those that are not familiar with the listeners, it's a deep learning framework. It was launched pretty early on. It was a kind of an open source effort. It's an Apache Foundation project. And AWS was really trying to push MXNet back then as an alternative to TensorFlow. And later on, as PyTorch gained more popularity, also as an alternative to PyTorch. And obviously for a cloud provider like AWS, having their own deep learning framework that they can optimize on their infrastructure, on their services, kind of is very important. However, it didn't pan out. And, I actually thought a lot about kind of why did it not pan out. And I think really there are different reasons, but one of the core reasons is MXNet focused a lot on performance. Whereas PyTorch, which really picked up, became very successful, a great project, focused on ease of use and user experience. And performance definitely came in to PyTorch for sure, but it kind of came in a bit later. And I think that was a very significant design choice, where performance was set aside a little bit to focus on ease of use. And I think this is a key thing for every developer tool, right? That was an important learning for me and for the team back then. Now, going back to your question about, TensorFlow. I think it's very clear that PyTorch is dominant, especially around language modeling. And language modeling, with ChatGPT and other similar models is all the rage these days. And this is why PyTorch gets a lot of, mindset. However, TensorFlow is still, very popular. In particular, what I find is that it's very popular for computer vision applications. You mentioned one of the deployment scenarios for computer vision applications is on the edge. And I think that's where TensorFlow tooling is actually really good. I would also say that, Keras, which kind of got integrated into TensorFlow, is a fantastic library. It has an amazing ease of use. I actually got my first steps with deep learning with Keras. And I think it still has a lot of people that like it and that get important work done with Keras. So I think, TensorFlow is definitely still there. Although for, language modeling, large language models, it's definitely has been somewhat absent. And I think some of the design decisions that the TensorFlow team made make it a bit less useful for language models. So the fact that PyTorch is, still just Python code makes it extremely attractive for folks who develop language models.
So for our listeners, Hagay, who've heard the word JAX thrown about, what's your sense? So my sense is in the language model space, it's mostly PyTorch, but there's some JAX, particularly obviously from Google, DeepMind, and outfits like that. But also some papers are still written using JAX. So what's your sense of JAX? Worth learning or not worth learning?
So I think at this point it's still a bit esoteric. My observation is that it's used mostly within Google, and the support for NVIDIA GPU is still very limited. It works really well on TPUs, but then getting access to TPUs is a bit more difficult. So I think, worth learning or not, it really depends on the person. But I would say if you want to kind of focus on, building models, trying them out, messing around with that, I'd say for language models, definitely PyTorch is the way to go. JAX is still not there. But it would be interesting to see, I think a vibrant ecosystem with different alternatives is a good thing for everyone.
By the way, I've recently just got involved with an interesting project, which we don't have to talk about, called Ivy, which is basically a transpiler where you can take, for example, you read a paper on PyTorch, but your team uses TensorFlow. So Ivy will just basically transpile that code over to TensorFlow rather easily. So in many ways, it's like the next generation of ONNX, but with a startup behind it, so maybe there's going to be more resources. All right, so the main topic for today is what I'm calling decentralized custom models. By that I mean I think that there is kind of right now the situation is a lot of these models, particularly the large models, when you look at the number of large models on paper, there's a lot of them. Maybe, for example, language models, maybe you can say there's about 30 of them. But then the number of organizations who train them is really small. For example, GPT is now up to 4, right? So OpenAI has 4 of them. But Hagay and I shared this kind of perspective that maybe we're still in the early days. When this all plays out, more people will be training these foundation models. So, Hagay, what's your rationale for this belief that over the long term, there'll be a lot more people training large models?
Yeah, so I think there's really different angles for that, but the key thing is that it's becoming very clear that large language model, it's not just a toy, it's not just a fancy demo. It has real value, and I think now we see an enormous amount of startups are trying to figure out how they can deliver value, monetize the value, etc. Writing assistants, coding assistants, summarization, reviews. There's a lot of super interesting business use cases that are built around them. So, and then the question comes, okay, so is this going to be a world where, a handful of companies produce these big models, and then everyone else builds on top of these canonical models? And I'd say that looks like it's the OpenAI vision, right, for the world. I tend to think there's definitely going to be some of that, right? Because not everyone needs to build their own model. But I expect actually this to be the smaller part of the ecosystem, because what I'm seeing talking to different companies, both previously as well as currently at MosaicML, that there are some limiting factors for companies to use someone else's model. The first thing is, IP ownership, right? When you don't own the model, right? When your model is someone else's IP ownership, but you use it for a key business use case, you're risking not having a moat for your business. I mean, your competitors can very quickly just get the same level of AI sophistication as you have just by buying the same service from that company. It's very hard to differentiate yourself, right?
So let's do this. So each point you make, I'll play devil's advocate, even though I agree with you. Okay. So IP, well, but then what if I guarantee that your data that you feed into the model is isolated from your direct competitor?
Yeah, so that would help for sure in that regard, right? So then if I did fine tuning on that external model, my fine tuned model remains mine. But then, I don't think that necessarily, right, always that data that you use to fine tune is really that hard for others to get. A lot of the barrier for entry or the difficulty is actually, the base model, right? That's where a lot of the sophistication is. Yeah.
All right. So the other thing that this brings to mind that I point out, I don't know if you agree with this, is also just your ability to innovate.
Yeah.
In other words, if I'm reliant on someone's API and I need something, then I have to wait for them to add that.
Exactly. You have to wait for them to add that. They may also deprecate a model at some point that you rely on, right? So again, I think if the AI use case is like a small thing, not that important, maybe it's something that doesn't matter too much. But if it's a key key capability of the service or application you're selling to customers, to end users, that can be a big risk factor. Yeah. Now, relating to that, another thing is, data privacy and compliance. There are a lot of companies out there saying financial industry, healthcare, legal, where they're actually not even allowed to send their data outside of their premise. And at MosaicML, we actually talk to a lot of companies like that need to train their own models exactly because of that. And so they actually need to be in a situation where, it's their own model, and it's even more than that. That model never leaves their premise. The data they use to train it or fine tune it or even run inference never leaves their premise. So that's actually a huge limiting factor for quite a bit of the verticals out there.
All right. So now my counterpoint.
Yeah.
So you came from AWS.
Yeah.
Right. So isn't this the same argument between companies were saying public cloud is never going to work because companies are not going to go to the public cloud? And yes, there's hybrid, but in the end, the cloud companies are huge. So
correct. Yeah. I think the big difference there is just the cloud companies. They are giving you an environment that is fully in your control, right? And there are different levels. I mean, there's the, even AWS has, the air gapped, right, cloud for government agencies, different security agencies and whatnot. So, and then even if you look at something a bit less restrictive than air-gapped environment, I mean, you have your own VPC, the virtual private cloud, where, you have a lot of security controls around the data that is running around over there, the services, and yeah, so that environment, for example, by the way, is also meeting regulations like HIPAA for healthcare and other regulations. So I think that's the big difference. I think if, cloud vendor, for example, anyone else would offer this level of security and compliance, and of course that's reasonable, right? That's what these companies need.
And so guys, before we go any further, so let's just clarify what we mean by a larger foundation model in the following sense. So we're not claiming that everyone will build a model as flexible as what powers ChatGPT, right? So not everyone will build a general purpose search engine. So what exactly is a foundation model or a large model in the context of an enterprise?
Yeah.
What does that mean?
Yeah, yeah. We can actually start with an example. One of our customers at Mosaic is a company in the finance industry, and the types of I can't go into too many details because of customer privacy, but they are focusing on building large language models to understand financial documents that are very specific to their use case. And if you look at the distribution of the data, it's extremely different than let's say the data sets that most open source or closed source language model out there have been based on, like the PI or C4, which is mostly Wikipedia articles, websites, etc. It's very industry specific document with a lot of jargon. Syntax is not really even standard English. And so what they are building is a language model, a foundational language model that can understand these documents and convert them into something they need downstream, either embeddings or other types of structured data. And this is one example of such a company-specific custom foundation model that is being built. And you can extrapolate that, think about domains like healthcare, and other domains where the jargon is very different and specific, or the use cases are very different. So these general purpose chat language models, for example, actually are not going to do a good job at that. And that was actually tested by some of these companies.
But the term foundation for our listeners comes from the fact that this model, as Hagay described, is trained on such specific data sets that once you train it, you can then use it for other downstream tasks, right?
Yeah, exactly. So these companies would train this model, and then they would use them for multiple downstream tasks. And there are different use cases. That's already kind of standard. For example, these models can generate embeddings, and these embeddings are then used for different downstream tasks, from classification to search to other things. Or these models can also generate, for example, structured data that is then again used for other downstream tasks that may not actually even involve machine learning specifically. But the idea there is that a company trains one large model, invests a lot of resources in training this model, refreshing it regularly on new data as it comes in, and then makes it available for downstream tasks. Now, this is, by the way, how, again, I'm going back to earlier in our chat when we talked about some of the big tech companies that are today operating in the future. This is how big tech companies already use this technology today.
So I'm an enterprise. I have a data science team. Maybe I have 10 data scientists on my team. Maybe one has touched deep learning before.
Mm-hmm.
So is this way beyond my capability?
Mm. Yeah, this is a great question. So I think there are different complexities, right? If you're an enterprise and you want to build such a capability, there are different complexities involved. I'd say one is more around the machine learning infrastructure. The other one is around the machine learning modeling, right? That's a kind of a very high level, rough separation. On the infrastructure side, training large models such as LLM, but also other types of models, carries a lot of complexity. I mean, the infrastructure is just immense, right? Just think about, Meta's OPT 175. It's a 175 billion parameter model. Meta, made available under certain limits, but they did share their logbook for that. It was trained on, thousands of GPU over more than 30 days. And they had more than, they reported that. So it's the data is open out there, reported more than 100 restarts that happened during that training. They shared the logbook of the training, and looks like that team had a really horrible time, right? Being able to train that model. Didn't get a lot of sleep, looks like it. And we're talking about Meta here, right? With hundreds of people building their machine learning infrastructure. So the infrastructure is complex. Scaling, orchestration, fault tolerance, all the fine tuning of the different hyperparameters specifically for scale. I mean, it's not trivial at all. It requires expertise and a lot of tooling.
Hardware utilization.
Yeah, hardware utilization. It's surprising how bad is hardware GPU utilization on large language model training. It's hovering around 50 to 60% for most, you know, if you look at NeMo Megatron by NVIDIA, and we're talking about NVIDIA here, the company that builds GPUs, 60%. And actually, it's hard to get to the 60%. So yeah, it's all of these things. These things are hard. And there are also things that, you know, I'd say your standard data scientist doesn't have too much, you know, expertise in, and also not too much interest in, right?
Honestly, Hagay shouldn't have to deal with.
Exactly. Yeah.
Right.
Yeah. 100%. So this is one concern. And by the way, just, you know, I'll plug in Mosaic here because that's exactly what we're trying to solve at MosaicML. We want to make large language models and other large models accessible to more companies. And we figured that, hey, we should focus first and foremost on the infrastructure because that's really hard. And that's also undifferentiated, right? It's the same concern whether you're a healthcare company, financial company, any other kind of company. It's kind of the same concerns.
And so going back to my question, how important do you think this notion of training your own foundation model will be? So one line of thinking I have is that with the emergence of ChatGPT, maybe the expectation of users, consumers, may have changed, right? So when I go to your website, maybe I want to be able to interact with some kind of interface like this. That delivers your company specific answers. So do you think having this capability will be essential? So in other words, if you don't have this capability, you're toast. The having your own foundation model.
I think so. And I think it gets clearer by the day. So, you know, let's take a step back for a minute. ChatGPT, as you said, is setting new expectation, not among technical people like us, but actually among the broader consumer folks around how the computer system should interact with the end user. You know, my parents are playing with ChatGPT, and my parents are not technical people, right? And they love it, and they're excited by it, and they are fascinated by it. And I know lots of other people that are not technical people that are excited by it. My kids are excited by it, right? They're trying to use it to do their homework, right? So there's definitely, it's a very significant shift that is happening. You know, it reminds me also about something a bit different. I remember when Transformers with BERT started to get popular, people said, hey, now it's the NLP, they're having their ImageNet moment, right? Or their AlexNet moment. And I think now it's clear that this is not the AlexNet moment or the ImageNet moment. This is actually the iPhone moment, right? And iPhone really changed the game, right, around what mobile phones are and what's the expectation are and what people are doing, right, with their mobile devices. And the world has changed dramatically since then. And I suspect that, you know, what we're seeing now is actually a change on a, you know, similar order.
And so a lot of what we talk about when we talk about foundation models, honestly, right now is text.
Yeah.
But do you think that other modalities will increasingly, obviously, other modalities have their own foundation models, right? So like in speech, in vision, and things like this. But by the way, I recently went into patent databases, and I noticed that actually when you look at patent filings around this topic of large models and foundation models, a lot of patents are actually in the speech area, which is not surprising because probably a lot of applications will be speech powered, right?
Yeah.
So do you think that right now companies should focus on building foundational text models as their first step into this area?
No, I think it really depends on the business of the company and their use cases for AI. Again, I think language models are all the rage these days, and they have been indeed super impressive. But there are really great use cases for, let's say, computer vision, right? Foundation models. For example, a company that handles a lot of image data may decide to build a foundation model for image understanding. That foundation model can generate, for example, embeddings for images and other types of attributes. And then that data is very useful for a lot of downstream tasks. It's actually how companies can be much more efficient and cost effective with AI, because if they don't do that, then they're going to build potentially tens or even hundreds of models that actually a lot of their processing is the same, just understanding the core aspects of an image. So I think computer vision is a great use case also for foundation models around that. If you think about video, the same. Video understanding is extremely expensive. Video is multimodal by nature, right? There is the image data, there is the audio signal. If you're smart about analyzing video, you have also an OCR component, optical character recognition, that reads characters and then uses that as text input that also feeds into that foundation model. And again, I've seen some of these models being built in different companies, and I think that's a hard task, and that's exactly, you want to build foundation models for these hard tasks that have a lot of downstream use cases. So I definitely think companies need to think beyond just text. Although, I recognize that, language models have been so fun to play with, and that's part of why they get a lot of mind share.
So going back to my question about accessibility. So you addressed the question, infrastructure is hard. Maybe there's solutions on the way on infrastructure.
Yeah.
But models are also hard in the following sense. As I described, I have a data science team. None of us are deep learning experts, for example, right? So I'm painting this scenario, which is common, by the way.
Yeah.
I know that we're now starting to see artifacts in the open source of starter models, right? So
yeah,
from academics, from collaboratives and things like this. But one thing I caution readers is to always read the license or you proceed and invest in a specific open source model. So am I right to say that there's starting to emerge this artifacts in the open source, the starter models, starter data sets, and things like this?
Yeah, definitely. So I think just like any new technology, initially the tooling sucks and it's actually really hard to get started. But as technology domain matures, there's more tools out there. These days in machine learning, like the open source community is just incredible, right? Not just for models, but also for tutorials and training. Then, it's worth giving a shout out, Fast AI really kind of made everything so accessible, so democratized.
Hi, Jeremy.
Yeah, yeah, definitely. Jeremy Howard did an incredible job at just making.
But still, are there enough starter models?
So
people to work.
Yeah, so I think we're getting there, right? I mean, you're seeing, the Luther AI team, right? Working group coming up with.
Are the licenses friendly?
Yeah.
Right.
So yeah, I think it's I think that's a really good point, because they're not always. You have to really read the details. Some of them are, some of them are not. Like some of the, especially licenses, of models coming from the big AI labs, like at FAIR, at Meta. You need really to read them, because these companies tend to be very cautious and careful. So their licenses will typically not allow commercial usage. But I think it's just a matter of time. I think we've seen that look at what happened with DALL-E, right? OpenAI DALL-E was, everyone were excited about it, but it was behind that API wall. And then very quickly, all the, different research lab came up. Stable Diffusion is out, and, Stable Diffusion is just there for everyone to use and enjoy, and it performs.
It's not as good as DALI, though, I can say.
Yeah, but I suspect it will get there. And again, if you look at the history, open source technologies tend to catch up and often exceed, actually, right, the closed source solutions. And I'm not sure if this exactly will play out similarly for machine learning, because the big difference is in machine learning compute is extremely expensive and is still limited. And then the private labs or companies have an edge in that regard.
By the way, Hagay, along those lines, there's an interesting, I don't know if it's a counter trend, emerging trend around the scaling laws for these models, which generally the scaling laws seem to indicate the larger the model, the better it is. But recently, there's been two kind of good counterexamples. One is called Llama from Meta, and then Chinchilla from DeepMind. And in both these cases, it turns out that I wouldn't call them small models because they're still many, many billion parameters. But let's say they're mid-sized models, and they're just as good, but they're trained on more data. So maybe there's some hope for companies out there, as maybe there's some trends that point to more reasonably sized models. Let's put it that way.
Yeah, and I think over there, there has been a bit of unnecessary or incorrect obsession with the number of parameters. And, so it's interesting, right? Because what Chinchilla and Llama showed us actually is that models like GPT-3, 175 billion parameter, was actually undertrained. So with Chinchilla, they were able to train a 60 billion parameter model that actually performed better in terms of accuracy and different evaluation metrics than GPT-3 with 175 billion parameters.
Just 60 billion, huh?
Yeah, just 60. But what they did is they trained it on, I think, 1.4 trillion tokens, so like 2 to 3x what GPT-3 was trained on. And similarly, even smaller models than 60 billion, right, with more data, it performed much better. So I think the notion there is that, of course, obviously more parameters help the model generalize, learn better. But then the amount of data, and I think people don't talk about that enough, but even more importantly, the quality of data, right? That actually matters a lot. Now, I even think for most business use cases, you don't even need to go to the, tens of billions of parameters. I mean, GitHub Copilot, it's a fantastic tool. It's a 4 billion parameter model that is powering it. That's it. And I think we all agree that it's a really useful tool. It's domain specific, so it's not as general purpose as other things. But again, if we talk about a company that really wants to get a specific business use case done well, right, it doesn't have to be general purpose, right? They can focus on the specific domain. So we have a great example of a useful tool powered by a, only, right, 4 billion parameter model. Now, 4 billion parameter model, on the MosaicML platform, you can train for about $30,000 to $40,000. Now, it's nothing to sneeze at, but it's also not millions of dollars like what's been advertised for the bigger models. Another example, by the way, relevant to that is one of our customers at MosaicML is Stanford CRFN, so that's Percy Liang's team. They built a model called BioMedLM on our platform. It's a language model for the biomedical.
Yeah, 4 billion parameters, right?
Yeah, 3 billion parameter actually, or 2.7, I believe, to be more accurate. It's a GPT style model, decoder only. It actually outperformed Meta's Galactica, right? Which Galactica is about 120 billion parameter. It outperformed Galactica specifically on evaluation for this domain, for biomedical domain. But, it costs like 5%, I'd guess, of what it costs to train Galactica. And even if you put training aside, look at inference, serving a model that is more than 100 billion parameters is usually impractical for any business use case, right? It's just too expensive. So I think the lesson here is that, yeah, a lot of parameters help, but you don't need as much as you may think.
And which means that looking ahead, we'll probably see a lot more of these mid-sized models as researchers uh, push them out. And this also makes it more likely that more research teams will be capable of pushing such mid-sized models out instead of the handful of research teams we have today, right?
Yeah, I think that's the future I'm hoping for, right? I think a vibrant ecosystem with a lot of players is what's going to push the AI field forward. I mean, we're not going to stop with transformers, right? There's going to be another innovation that will come out that will take us to the next level. For this to happen, we need a vibrant ecosystem with a lot of researchers working, making progress, sharing, right, their work rather than keeping it closed. That's what we need for the field to progress.
And so in closing, guys, so we are now for young people in the tech industry who have never seen a kind of a downturn in the
Yeah.
funding environment and the startup environment, right? So the job market is a bit tougher.
Yeah.
So do you think it's possible to do what you did back in the day, which is to go from tech to ML now that things are cooling down in tech more broadly, although ML seems still hot? So
Yeah.
what's your advice to our listeners who are looking to move from like a programming job to a more ML related job?
Yeah. First thing I'd say is one of the reasons I really love, right, the field, and I'm happy that I chose this career path, like, I don't know, 20 years back or whatnot, is that it's so diverse. You can do so many different things, work across so many different industries, and really, advance your knowledge and kind of your understanding constantly, because, technology is always changing. Um, and with this in mind, I think definitely there are always great opportunities for those who are curious and who are willing to take some risks to get themselves out of their comfort zone, right? And you gave my example. I mean, I definitely kind of decided to step into machine learning when I had the opportunity to do it. But I also took, you may think, even like a step back in my career, where I took like a smaller role, right, than what I did before. But I did it because I could, I was really excited about machine learning and very specifically deep learning. And I saw the opportunity, and I just wanted to kind of have, take part in that amazing ride. And I'm happy that it didn't, it kind of met my expectations in many ways, probably even exceeded it, because the field has been really exploding. But I did have the curiosity. I took a lot of time, personal time, to learn things, go through, we talked about Fast AI earlier, to go through Fast AI, Coursera, and just, grind through to learn the basics. Now, I would say, I think many people think that, hey, to do machine learning, you need a PhD. And I think it's definitely one way, right, to get into machine learning, but it's not the only way. And I think it's usually a way that actually doesn't even fit most people. I think if you are a capable software engineer, and you have curiosity and you have strong foundations, right, in the field, then it's definitely just putting the time to learn a little bit, look into roles where you can, your experience can make a difference and contribute, and then just, find these opportunities and build yourself in that field.
And honestly, while we're both sitting in Silicon Valley, this is a technology movement that will dominate the entire planet. So you can do this from anywhere in the world, in any company. As Hagay, I liked how Hagay puts it. You might have to step into a role. So you may have to raise your hand and volunteer, and you may have to put in the work at nights and weekends to learn. And to the managers listening, you may have to nurture and be patient as your team members step into the role and learn.
Yeah, definitely.
Yeah. And with that, thank you, Hagay.
Thank you, Ben. It's been awesome to be here.